बिस्मिल्लाहिर्रहमानिर्रहीम अस्सलाम वालेकुम, कैसे हैं आप? This is lecture number 25. Let's start. So first we take a review of last lecture. In last lecture we have discussed the probability distributions of a continuous random variable, and in particular we have discussed the uniform distributions, and we have discussed some of the important properties of uniform distributions, and then we discussed in the last lecture that how we can use MS Excel to generate uniform random numbers, and how we can use MS Excel to generate random numbers from any other distributions. And then we have discussed some of the related examples which are related to the uniform distributions, and how we can solve questions which are related to the uniform distribution. So let us discuss the objectives of the current lecture. In the current lecture we will discuss one very important distribution for the continuous random variable. So it is the normal distribution, and we will discuss probability density function of normal distribution, and we will also discuss some of the very important properties of the normal distributions, and we will try to cover the related examples as well. So let's start. The normal distribution. Normal distribution is considered as the cornerstone of the modern statistical theory. It is also called the Gaussian distribution, or simply the Gaussian, in the honor of great German mathematician Carl F. Gauss. Karl Pearson called this distribution as the normal distribution, and it is the best known by this name. So importance of normal distribution. So normal distribution is useful because many things actually are normally distributed or very close to this normal distribution. So for example, height and intelligence, they are approximately normally distributed, and measurement errors, they are also often have a normal distribution. The normal distribution is easy to work with mathematically, and computations of probabilities in case of normal distributions, they are direct and elegant. The normal probability distribution has led to a good business decisions for a number of applications. In many practical cases, the methods developed using normal theory, they work quite well even when the distribution is actually not normal. So there is a very strong connection between the size of the sample and the extent to which a sampling distribution approaches to the normal form. So many sampling distributions based on large n can be approximated by the normal distribution, even though the population distribution itself is not the normal. So when sample size increases, so most of the distributions, they converge to the normal distribution. So hence we can say that the normal distribution closely approximates the probability distributions of a wide range of random variables. So let us formally define the normal distribution. So normal distribution is a bell-shaped curve. So here is the bell-shaped curve. So on x-axis we have the random variable x taking different values, and on y-axis we have the probabilities or the corresponding frequencies. So note that the normal distribution is a symmetrical distribution, that around this middle line, it is equally spreaded around this middle line. So equally spreaded around this middle line means on left hand side of this middle line we have the 50% of the area, this area to the left of this middle line, and similarly area to the right side of the middle line is the remaining 50%. So it means this middle line, which is also called the line of symmetry, it divides this bell-shaped curve into two equal parts. So 50% on the left hand side of the middle line and 50% of the area on the right hand side of the middle line. And remember that this middle line where the peak of the normal distribution occurs, it is always equal to, here x takes value equal to its mean. So at mean the peak of normal distribution occurs. So whenever x is equal to its mean, we get the highest probability of this normal distribution. So at x equal to mean, you can see that we are getting the highest probability. And in case of normal distribution, mean, median and mode, they are all equal. So here is the mean, and median is also occurs at this point, and similarly mode also occurs at the same point. So mean is same as median, which is same as mode. So location of the distribution is determined by the mean mu. So if we shift this mean, say currently it is at, let's say, 0. So if we shift this mean from 0 to any other value, say 1, so then the location will be, then the shape of the distribution or the full distribution will be shifted accordingly. So suppose this is the original shape. So here mu is 0. So this is the 0 point. So if we shift this mu from 0 to 1, so then the normal distribution will be shifted to 1. So the highest probability will occur at 1 now, because mean is shifted to 1. Similarly, if you shift the mean instead of 1 to suppose -1, so then the normal distribution will be shifted to this -1. So the location of the distribution is determined by the mean, whereas the spread is determined by the standard deviation or the sigma. So sigma measures the spread. If sigma is a small number, we will see a low spread, and if sigma is a big number, we will see a large spread. So in order to explain it, suppose this is our original normal distribution with suppose mean 0 and suppose sigma equals 1. So now suppose we have a normal distribution with same mean 0, but this standard deviation, it decreases from 1 to 0.5. So in that case, this is a new distribution with sigma equals 0.5. So you can see that the spread of this new distribution, it is now decreased. And if we have another distribution with same mean 0, but standard deviation suppose increases from 1 to 1.5, so in that case this will be somewhat of this shape. So you can see that the spread of the distribution, it got increased from 1 to 1.5, whereas since the peak in all three curves is same at 0, so we will say that the mean is 0 in all three cases. The theoretical variable x in this case has an infinite theoretical range, that is, it ranges from -infinity to +infinity. So here we can draw -infinity to +infinity. So x can take any value within this range from -infinity to +infinity. So let us define the normal probability density function. The formula for the normal probability density function is f of x equals 1 over square root of 2 pi times sigma into e raised to power -1 by 2 times x minus mu over sigma whole square. And here this e is a mathematical constant which is approximated by 2.71828, and pi is another mathematical constant which is approximated by 3.1 14159, and mu is called the population mean of this random variable x, and sigma is called the population standard deviation. And x is any value of the continuous variable from minus infinity to plus infinity. So if x is a random variable which follows normal distribution with mean mu and variance sigma square, then we use the notation that x is distributed as normal with mean mu and variance sigma square. And remember that mu and sigma square, which are respectively mu stands for mean and sigma square for variance, they are also called the parameters of this normal distribution. As we have already discussed that once we have the values of parameter in hand, we can tell anything about the distribution. So mean and variance, they are the two parameters of the normal distribution. So if we know the value of mean mu and the variance sigma square, we can tell anything about this normal distribution. So parameters are also called the driving forces. So plotting normal probability density function in MS Excel. So let us discuss the working steps of plotting the normal probability density function in MS Excel, that how we can use Microsoft Excel spreadsheet program to draw the bell-shaped curve, which is the density function of a normal distribution. So first take mean and standard deviations. We can assume any value of mean and any value of standard deviation, and remember that since standard deviation cannot be negative, so we have to take positive value of standard deviation, whereas the mean can be positive, can be negative. So then take any x values, so suppose from -5 to +5 with step size of 1. So actually the range of x is from -infinity to +infinity. So we can take any value of x. So here in this particular case I am taking x from -5 to +5 with step size of 1 mean. So first number will be -5, then the gap of 1, next will be -4. So gap between -5 and -4 is of 1 unit. Next will be -3, -2, -1, 0, 1, 2, 3, 4 and +5. So instead of taking the range of x values from -5 to +5, you can experiment by taking range of x values from -10 to +10 or -20 to +20, or you can even take positive values or only the negative values of x. So we will see that what are the plausible values. So actually these values are related with the choice of mean and standard deviations, so which we will demonstrate later in our Excel spreadsheet demo. So after taking the x values, calculate normal probabilities using the probability density function formula, so with corresponding to each value of x. So here just replace this x by suppose -5. So here replace x by -5, and suppose mean is fixed at 0 and suppose standard deviation is fixed at 1. So -5 -0, and this sigma is 1, this sigma is 1, pi is 1 constant, e is also constant. So you can simplify this expression. So you can use calculator or MS Excel spreadsheet program to calculate the probability when x is -5. So similarly replace x by instead of -5, then replace x by -4, while keeping the same value of mean, which is 0, the assumed value, and the standard deviation sigma 1. So we can again calculate another value, a value of f of x corresponding to x equals -4. Similarly replace x by -3, -2, -1, 0, +1, +2, +3, +4 and +5. So once we have all the probabilities, so in the end construct a scatter plot of x again this f of x. So this will produce a bell-shaped curve. So let us demonstrate how we can use this probability density function formula to get the normal probability curve. So here is our Excel spreadsheet program. So here is the density function of x, where x follows normal distribution with mean mu and variance sigma square. So in Excel spreadsheet program, construct a column, labeled this column as x, and here take any values, so -5, -4, and copy this range up to +5. So I have generated x values from -5 to +5, and here type mean mu. I'm taking mu 0 and standard deviation I'm taking 1. So later we will experiment by changing the mean from 0 to any other value, and then we will experiment by changing the standard deviation from 1 to any other value. So currently I have taken some fixed values of mean and standard deviation. So now I have to type this formula f of x here in next column. So this is f of x. So now we need to type this expression using Excel formula. So look at this expression on the right hand side. It is 1 over square root of 2 pi times sigma. So I'm just calculating this first expression here in this fraction. So just type an equal sign. So 1 divided by sqrt square root, and here we have 2 times pi. So 2 steric pi. In order to calculate pi, we have a built-in functions. The built-in function is pi pi and then the 2 parentheses. So that's it. So I have closed the parentheses. So 2 times pi. So this will be this will multiply the number 2 with pi, and then we are taking square root of this product. So square root and then the 2 parentheses, and within the parentheses we have 2 times pi. So it means this command will calculate 1 over square root 2 pi. But remember that here, as far as this right hand side is concerned, this square root 2 pi, it is being multiplied with sigma as well. So just multiply, put a asterisk here, and then multiply this sigma, where sigma is located in E2. So as far as this full command is concerned, it is square root 2 times pi times sigma, and then 1 divided by this full amount. So it means we have to put 1 parenthesis here, and at the end we have to put parenthesis here. So why I have used the parenthesis? Because I want that Excel first calculate this expression in the denominator. So once this is completed, then 1 should be divided by this resultant number. So this is very important to note in Excel, that you have to put the parentheses in proper order. So this will calculate 1 over square root 2 pi times sigma. So then we have to multiply this full expression with e raised to power certain number. So asterisk for multiplications, and for e we know that we can use exp1. This exp1 is used to represent this e, and then we have to take this full expression as a power of e. So then put this cap sign for the exponent, and its exponent is -1 by 2. So -1 by 2, since the power is a negative number, so I'm writing it in parentheses. So minus 0.5, which is 1 by 2, and this -1 by 2, it is being multiplied by this whole square, x minus mu over sigma whole square. So just put the asterisk for multiplication. So -1 by 2 times x minus mu, so put parenthesis instead of x, write this first entry, first value of x, which is in A2, minus mu, mu is in mean, which is in E1, divided by sigma, sigma is in E2, and we have to take square of this whole expression, x minus mu over sigma. So in order to square it, just put one more parenthesis. So it means this will do what? It will first subtract E1 from A2, so x minus mu divided by sigma, which is located in E2, and then this parenthesis cap sign 2 whole square. So now we can see that exp1 mean e raised to power, this cap sign for power, and then minus 0.5 times x minus mu sigma, and at the end we have to close this parenthesis which we have started at here. So this is closed here. So that's it. So this is how we can use MS Excel to calculate probabilities. So 1 over square root 2 pi times sigma times e raised to power minus 0.5 times x minus mu over sigma whole square. One more thing, that we have to fix the mean and standard deviation by putting the dollar signs. So dollar before the column heading and dollar before the row heading. And here again you have to fix E1, which is mean, and the standard deviation, which is in E2. And note that I have not used the dollar signs with A2. Why? Because when we will copy this command downward, this A2 will be changed to A3. So it means this f of x will be calculated for the next value of x, which is in A3, which is actually minus 4 in this case. Similarly, when you copy it further down, so then the x will be minus 3. So for minus 3, the same formula will be calculated. And remember that since we have used the dollar signs, so it means the mean and standard deviations, they will be fixed. So every time when these calculations, when these expressions are being calculated. So this is how to write this density function formula in MS Excel spreadsheet program. So press enter. So it is 1.48672 e minus 0.6. So it means it is very, very small, 0 to the 5th digit. So just copy it down, so you can see that. So now A2 changes to A3, whereas E1, E2, they are the same due to dollar signs. So copy it further down. So you can cross check it. Now it is A7, and that's it. So this is how we can write this probability density function in MS Excel. So in the end, you have to select both columns, x as well as this f of x, with the help of this mouse, and go to insert and make a scatter plot. Scatter and scatter plot with smooth lines and markers. So here is the bell-shaped curve. I'm going to move it to new sheet. So right click and select move chart from this menu. So select new sheet, click OK. So here is the normal density, normal probability density or bell-shaped curve. So let me increase the font size. So you can see that the peak of this normal curve, it is at 0. So when x is 0, we get the highest probability, which is around 0.4 or 40%, or actually it is 39.89%, which is being shown in the Excel tooltip. So note that this 0 value is actually the mean. So it means the highest probability of normal distribution, it always occurs at its mean value. And this standard deviation is 1. It is it gives us the spread of this normal distribution. So now if we change mean from 0 to 1, so I have changed the mean from 0 to 1. Now see that since the cell references E1 is used, so now E1 is changed to 1, so it means all the calculations, they have been readjusted according to this value 1. Now look at the chart. So you can see that this chart is now, this peak is shifted to 1. So now this peak is at x equals to 1. So it means the highest probability or peak of the normal curve, it always occurs at its mean value. So let us experiment by changing the mean from 1 to -1. So again these values have been recalculated and now the peak shifted to -1. So we can again experiment with 2. So now the peak is shifted to 2. And similarly you can experiment it by changing the mean to take any other value, either in plus value, or the minus values. So and remember that suppose I shift the mean to 3. So now look at the graph. So peak is shifted to 3. So it means in this case we need to take some more values to get a proper bell-shaped curve. So let me shift the mean from 3 to 4. So now you can see that we are not seeing a proper bell-shaped curve. Why? Because the range of x value is from -5 to +5. So it means in this case, since the mean is at 4, so we need to take the range of x by taking some values before the mean and some values after the mean. So it means here in this case we can take x from 0 to, let's say, 8. So 4 is in the middle, so we need to take few values before this 4 and few values after this number 4 in order to see a proper bell-shaped curve. So let me change the mean back to 0. So you can see that this is the original bell-shaped curve with mean at 0. So it means by shifting the mean we can see that the whole bell-shaped curve, it shifts accordingly. So it means the location of the distribution, it changes according to the mean. So now let us change the standard deviation. So currently the standard deviation is 1. So if we increase it to, let's say, 1.5, so numbers have been recalculated. So look at chart. So you can see that now its spread increases as compared to the previous spread. So now if we increase it further from 1.5 to 2, so you can see that the spread increases further. Let us take value back to 1. So this is the usual bell-shaped curve. Now decrease the standard deviation from 1 to, say, 0.5. So now look at the graph. You can see that the spread got decreased. So in this shape you can see that the curve is now very closely packed. So it means the mean and the standard deviation, these are the two driving forces. So once we have the mean mu and the standard deviation sigma for any normal distribution, we can tell its full characteristic. So all the characteristics of a normal distribution, they depend upon the two parameters of the normal distribution, which are respectively the mean and the variance. So the normal distribution shape, so changing mu shifts the distribution left or right. If mu is changed from, let's say, its current value to any value, any positive value, then the shape of the distribution, it shifts rightward. And if mu takes negative value, so it shifts leftward. And similarly, changing the standard deviation or sigma increases or decreases the spread. So this is the lesson which we have noted in our Excel demo. Many normal distributions, So you can see that by varying the parameters mu and variance or standard deviation, we can obtain different normal distributions. So for each value of mu and sigma, we get one different bell-shaped curve. So here we have represented the three bell-shaped curve, and you can see that each of these three bell-shaped curve, they have different values of mean and sigma. So now let us discuss some of the very important properties of the normal distribution. So first property is the function f of x defining the normal distribution is a proper probability density function, which is also called PDF in short. That is, f of x is greater than or equal to 0 for all x, and second one is that the total area under this normal curve is equal to 1. That is, the integral of f of x dx where x ranges from minus infinity to plus infinity, this is equal to 1. So these are the two properties for a probability density functions. So normal distribution is a proper PDF. So it means f of x is greater than or equal to 0 for all x, and the total area under this normal curve is equal to 1. So that is, here is the bell-shaped curve, so this full area is equal to 1. So since the range of x is from minus infinity to plus infinity, so this full area can be represented with the help of an integral, and the range of integral is from minus infinity to plus infinity, and this bell-shaped curve is f of x. So integral of this f of x dx, it is equal to 1. The second property is that mean and variance of normal distribution, they are mu and sigma square respectively. The median and the mode of the normal distribution are each equal to the mean of the normal distribution, or in other words, we can say that mean is same as median, which is same as mode. So mean, median and mode, they are all equal in case of normal distribution. So here, as far as this bell-shaped curve, so this middle line where the highest probability occurs, here we have x is equal to its mean, the same value is median, and the same value is mode. Next property is that the mean deviation of the normal distribution is approximately 4/5 of its standard deviation. Mathematically, we can write it as MD for mean deviation. It is 4/5 times sigma, where sigma is the standard deviation. Next property is the normal distribution has points of inflection which are equidistant from the mean, that is mu minus sigma and mu plus sigma. So these are the 2 points of inflection of the normal distribution. So remember that the point of inflection is defined as a point at which the concavity of the function changes. So this is the point where the curve changes its behavior or changes its curvature. So this point here, it is x equals to mu minus sigma, and this is the point where x equals mu plus sigma, and at the middle x is equal to its mean, the point where it takes the highest probability or the peak of the normal distribution. So the points of inflections are equidistant from the mean. So this distance is equal to the this distance. So it means if we add the same number to the mean, which is standard deviation sigma, so mu plus sigma, we can arrive at this point, and if we subtract the same number sigma from the mean value or mu, we arrive at the next inflection point. So the points of inflection, next inflection point, so the point of inflection of normal distribution, they are mu minus sigma and mu plus sigma. So in short, we can write the points of inflection as mu plus minus sigma. Next property is that for normal distribution, all odd order moments about mean are 0. That is, mu 2n minus 1 is 0 for n equals 1, 2, 3 and so on. Remember that this 2n minus 1, it is the general form to represent an odd number. So just replace n by 1 here. So it is 2 into 1 minus 1, so which is 2 minus 1, so which is 1. So when n is replaced by 2 here, so 2 to the 4 minus 1, we get 3. So when n is replaced by 3 here, 2, 3, 6 minus 1, 5. So you can see that we are getting odd numbers. So this is the general notations to represent an odd number. So here mu 2n minus 1, so it means this notation is used to denote odd order moments about mean. So all odd order moments about mean, they are 0 for all n equals 1, 2, 3 and so on. And all even order moments about mean, they are provided with the help of this formula, which is given by mu 2n equals 2n minus 1 into 2n minus 3 into 2n minus 5 and so on up to 5, 3, 1 times sigma 2n. So here again note that this 2n is used, or it is the general form to represent an even number. So just replace n by 1, you get 2. When n is 2, you get 4. When n is 3, you get 6. So you can see that you are getting even numbers. So 2n is the general form to represent an even number, whereas 2n minus 1 is the general form to represent an odd number. So here the notation mu 2n means the even order moments. So if n is 1 here, so it will be 2 into 1, 2. So it means second moment about mean. So just replace n by 1 here. So it is 2 into 1, which is 2, 2 minus 1, so which is 1. And here just replace n by 1. So 2 into 1, which is 2, 2 minus 3, you get minus 1. So whenever you get a negative number, so it means you need not include that entry. So it means we can consider only the first term of this product, and last one you need to write this expression sigma 2n. So just replace n by 1. So it is sigma square. So mu 2 is sigma square. So second moment about mean is sigma square. So we know that the second moment about mean is the variance, which is sigma square. So if we replace n by 2, so we get 2 to the 4, which is mu 4, the fourth moment. So replace n by 2 here. So 2 to the 4 minus 1, you get 3. And replace n by 2 here. 2 to the 4 minus 3, you get 1. So it means you got last two numbers. And here replace n by 2. So you get sigma 4. So it is 3 times sigma 4 is the fourth moment about mean in case of normal distribution. So similarly, replacing n by 3, 4, 5 and so on, you can get the higher order odd moments, higher order even moments. So next property is, if x is a random variable which follows normal distribution with mean mu and variance sigma square, and if y is another random variable which is equal to a plus b times x, so it means y is a linear combination of x where a and b are any constant numbers. So since this x is normal, or it is normally distributed, or it is a normal random variable, so y is a linear combination of x, so y is also a random variable and y will also follow the normal distribution. So but question is, what is the mean and variance of this random variable y? So in order to calculate mean of this random variable y, we know that mean of y is expected value of y. So expected value of y is expected value of right hand side. So just apply expectation on both sides. So here we know from the formula of the expectation that expected value of a plus b times x is a plus b times expected x, and expected value of x is, this is expected value of x which is mu, so a plus b times mu. So mean of random variable y is a plus b times mu. So we can say that y is also distributed as normal with mean a plus b times mu. Now question is, what is the variance of this random variable y? So it is b square times sigma square. Now how it is calculated? So since this y is equal to a plus bx, so variance of y will be the variance of right hand side. So since variance of constant is 0 and variance of b times x, so it will be simplified to variance of b times x, and we have already studied the properties of variance as well. So variance of some constant times random variable is the square of constant times variance x, and writing b square as it is, the variance of x is, this is the variance of x which is sigma square. So the variance of random variable y is b square sigma square, which is written here. So if x is a random variable which follows normal distribution with certain mean mu and variance sigma square, and y is a random variable which is formed by the linear combination of random variable x, so here y equals a plus bx where a and b are any two constants, so then y will also be normally distributed with mean a plus b times mu and variance b square times sigma square. So next property is the sum of independent normal variables is also a normal variable. That is, if x1 is a random variable which follows normal distribution with mean mu1 and variance sigma 1 square, and x2 is also a random variable which follows normal distribution with mean mu2 and variance sigma 2 square, and where x1 and x2 both are independent. So if both are independent, so then x1 plus x2, this sum, it will also be a normally distributed, and it is a random variable, say y, which is sum of x1 and x2, so it is also normally distributed, and the mean of y is the sum of means of x1 and x2, so mean of y is mu1 plus mu2, and the variance of y is sum of the variances of x1 and x2, that is sigma 1 square plus sigma 2 square. And remember that this formula is only valid when both random variables x1 and x2, they are independent. If they are dependent, so in that case the variance will also include the covariance as well, the covariance of x1 and x2. So but in case of independent random variables, the variance is variance of sum is sum of the variances. So here the variance of y is variance of x1 plus the variance of x2, that is sigma 1 square plus sigma 2 square. So next property is the quartile deviation QD is 0.6745 times the standard deviation, that is QD is 0.6745 times sigma. So if we know the standard deviation of the normal distribution, then we can multiply this sigma by this constant number 0.6745, we can calculate the quartile deviation. Similarly, the first quartile, it is equal to mu minus 0.6745 times sigma, and the third quartile is mu plus 0.6745 sigma. So if we know the value of mean and sigma, so if we know the mean mu and sigma standard deviation sigma, so we can use this expression to calculate first and third quartiles as well. So next property is normal curve is asymptotic to the horizontal axis as x approaches plus minus infinity. So here is the horizontal axis, so this is the x-axis, so it is asymptotic to the horizontal axis. So this means that normal curve approaches but never really touches the horizontal axis on either sides of the mean towards plus and minus infinity. So you can see that this bell-shaped curve, it is getting closer and closer to this x-axis, but it never touches this x-axis, so it gets closer and closer, and it actually runs in parallel with this horizontal axis on both sides. So here as well, so it runs in parallel. So this is called the asymptotes. This concept is the asymptote. So when x takes values plus infinity or minus infinity, so the normal curve, it runs parallel to the this x-axis, so it is getting closer and closer to the x-axis, but it never touches this x-axis. And next we discuss some empirical rules. So rule 1 says that approximately 68% of the area under the normal curve is between mu minus sigma and mu plus sigma. So here is the mean value or mu, so this point represents mu minus sigma, and here we have mu plus sigma. So the area that lies between mu minus sigma and mu plus sigma, it is 68.26%, or approximately we can say that 68% of the area under the normal curve is between these two limits, which are mu minus sigma and mu plus sigma. So symbolically we write it as probability that mu minus sigma is less than or equal to x, which is less than or equal to mu plus sigma. So this probability is approximately equal to 68%. So second empirical rule is approximately 95% of the area under the normal curve is between mu minus 2 times sigma and mu plus 2 sigma. So this is the point which represents mu 2 sigma. This is the point which represents mu minus 2 sigma. So it means from this interval mu minus 2 sigma to mu plus 2 sigma, or this range, it covers 95.44%, or approximately we can say that 95% of the area lies between mu minus 2 sigma and mu plus 2 sigma, or we can also write it in the form of probability that mu minus 2 sigma less than or equal to x less than or equal to mu plus 2 sigma, and this probability is 95%. And the third empirical rule is that approximately 99.7% of the area under the normal curve is between mu minus 3 sigma and mu plus 3 sigma. So here is the mu plus 3 sigma, and here we have mu minus 3 sigma. So this area or this area is 99.74% or approximately 99.7%. So 99.7% of the area under the normal curve is between mu minus 3 sigma and mu plus 3 sigma. So we can write it as mu minus 3 sigma and mu plus 3 sigma. So this area that x lies within these two limits, it is 99.7%. So remember that these three rules, they are valid for any value of mean mu and for any value of standard deviation sigma. So suppose if we fix mu at 0 and sigma at 1, so then the same rule can be simplified to, so just write mu, replace mu by 0 and sigma by 1, mu by 0 and sigma by 1, so we get 0 minus 1, so minus 1 less than or equal to x less than or equal to plus 1, so this is 68%. And here if we replace mu by 0 and sigma by 1, mu by 0, sigma by 1, so we get minus 2, so 0 minus 2 minus 2 and 0 plus 2 plus 2. You can write probability minus 2 less than or equal to x less than or equal to plus 2. This covers 95% of the probability. And similarly, by replacing mu by 0 and sigma by 1 here, so we get minus 3 and plus 3. So probability that x lies between minus 3 and plus 3, it is 99.7%. So similarly, if mu is different from 0 and sigma is different from 1, so we can calculate the range of x values by just replacing the mu by the appropriate value and sigma by the appropriate value. So you can get different range. So these three rules are very important. So here is the in-depth analysis of the same three rules. So you can see that here is the mean, or x equals its mean, and this is mu plus sigma and this is mu minus sigma. So by the empirical rule, we know that this area, the probability between the two, it is 68%. So since normal distribution is a symmetric curve, so it means this middle line, it divides this distribution into two equal parts. So if this total area is 68%, so it means if this is 68%, so this is the middle line, so it means area from mu minus sigma to mu, it is 34%, and area from mu to mu plus sigma, it is the remaining 34%. So 34 plus 34, we get a total of 68%. So it means from this rule we can write that mu minus sigma to mu, it is 34%, and mu to mu plus sigma, it is also equal to 34%. Or in notation we can write probability that mu minus sigma less than or equal to x less than mu, this is 34%, and similarly from mu to mu plus sigma, it is also equal to 34%. And note that these two rules, they have been derived from this probability mu minus sigma to mu plus sigma, total 68%. So probability that mu minus sigma less than or equal to x less than or equal to mu plus sigma, this is 68%. Similarly, this is point mu minus 2 sigma, and here we have mu plus 2 sigma. So area between the two, it is 95%. So it is 95% mean from mu minus 2 sigma to mu plus 2 sigma, it is 95%. Or in other words, we can also call it that it is 2 standard deviation range around the mean value. So this is mean. So you can see that we have gone 2 standard deviations or 2 sigma to the left of mean, and we have gone 2 sigma to the right side of the mean, that is mu plus 2 times sigma and mu minus 2 times sigma. So usually we write it as 2 times sigma or 95%. So again, this is the middle line, the line of symmetry. So it divides this total 95% area or probability into 2 equal parts. So this will cover half of 95, which is 95 by 2%, or it is actually 47.5%. So this area is 47.5%, and this is also 47.5%, and the total is equal to 95%. And remember that if out of this 47.5, if this is from this point to this, it is 34, then it means from this point to this point, it is 47.5 minus 34, and it is 13.5%. Similarly, on right hand side, if probability from mu to mu plus 2 sigma, it is 47.5, but it is subdivided into 2 parts. From mu to mu plus sigma, it is 34%. So it means this remaining probability, it will be 47.5 minus 34, which is 13.5%. And remember that this 13.5 is the probability between these two limits, mu plus sigma and mu minus, mu plus 1 times sigma and mu plus 2 times sigma. Similarly, the probability that mu plus sigma 3 sigma and mu minus 3 sigma, this range covers 99.7% area, or we can say that it is within x lies within 3 standard deviations, or we have moved 3 standard deviation on either side of the mean. So 3 standard deviation on left of the mean, so we are at this point mu minus 3 times sigma, and 3 standard deviation to the right of mean, so it means we are at mu plus 3 sigma. So if it is 99.7%, so this is the middle line, so it divides this 99.7% into 2 equal parts. So if we divide 99.7% into 2 equal parts, so 50% will cover this full area. So half of 99.7% is 49.85%. So out of this 49.85%, this area is 34%, and this one is 13.5%, which is 47.5%. So it means the remaining area between mu minus 2 sigma and mu plus 2 sigma, it is 2.35%. The difference between 49.85 and 47.50, which is 2.35%. Similarly, this probability or the area between mu plus 2 times sigma and mu plus 3 times sigma, it is 2.35%. So this is how we can use the empirical rule to find the probabilities within any 2 values of x. So let us review the main concepts which we have discussed in today's lecture. In today's lecture, I have introduced you to the normal distribution, which is the cornerstone of the modern statistical theory, and in particular we have discussed the probability density function of normal distribution and how we can use Microsoft Excel to draw the bell-shaped curve, and we have discussed certain important properties of the normal distribution, and we have also discussed some of the related examples, and we have also discussed the empirical rules for finding the probabilities within certain area around the mean, or in particular what is the probability that x lies between mu plus minus sigma, and what is the probability that x lies between mu plus minus 2 times sigma, and the probability that x lies between mu plus minus 3 sigma. So in next lecture we will discuss how we can calculate area under the normal curve. So we will also discuss certain related examples, and we will also discuss how we can use normal approximation to binomial distribution. That means how we can use normal distributions instead of binomial distributions when n becomes very large, and we will also cover some of the related examples to this particular situation. So till then, Allah Hafiz.